Hello, everyone, and welcome to today's webinar, Compliance Considerations when Selecting a GMP-Compatible Freezer. I am Marie Stone of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by Thermo Fisher Scientific. To learn more, visit thermofisher.com. We encourage you to participate today by submitting any questions you may have during the presentation. To do so, simply type them into the Ask a Question box and click Send. We'll answer as many questions as we have time for at the end of the presentation. You may also submit any technical issues here as well if you have trouble seeing or hearing the presentation. This webinar is educational and thus offers free continuing education credits. Please click on the Continuing Education window at the bottom of your screen to obtain your credits. I'd like to now welcome our speaker, Dean Rainbolt, Technical Applications Manager, Cold Storage Division, Thermo Fisher Scientific. Dean, you may now begin your presentation.
Well, great. Thank you, Marie. I appreciate the introduction. And I want to thank everybody for joining us today. I know everyone is stressed on time, and so I appreciate the attendance. Hopefully today, we're going to learn how to purchase a GMP freezer. So I think what the approach will be is we're going to purchase this thing together, and we're going to go through the different steps, if any, that we might want to take to purchase the correct freezer for GMP. So like Marie said, this webinar is compliance considerations when selecting a GMP compatible freezer. And so again, we're going to act like we're the customer, and we're going to try to figure out at least one process to get this done successfully. So if we have never met before, my name is Dean Rainbolt, and I am the Technical Applications Manager for the Controlled Temperature Technologies group at Thermo Fisher Scientific. Now, I've been there at Thermo Fisher for about 4 years, actually a little over 4 years. Now, before that, I spent a little over 28 years in the pharmaceutical industry. I was an asset manager for analytical testing labs, reference standards, laboratories, and storage applications there, development, stability, sample operations, and just general laboratory applications as well. I participated as an audit team leader and a subject matter expert. So that's a really floral way of putting, I was the guy on the hot plate when the FDA or someone else would roll in and want to perform an audit in our organization. And I also was an internal audit person. So if you don't do internal audits, that's a whole another talk, but internal audits are very important. I also did the asset management. I'm a member of the International Society of Pharmaceutical Engineering, or ISPE, in ISBR, the International Society for Biomedical and Environmental Repositories, both important if you're in the business of storing samples. I do have strengths in equipment validation and qualification. That seems to be a passion of mine, and I've authored a couple of temperature mapping protocols and procedures. So also I'd like in the wings, I'm going to have some support in the question and answer period. I have Jason Chen, who's our marketing development manager. He'll be available. Josh Lewis, who's the senior product manager for Thermo Fisher Connect platform, as well as Sarah Estrella with that group as well. So I have lots of support today. If I can't answer your question, hopefully we can get that done. So let's talk about the agenda. How hard can it be? So we're going to talk about considerations before purchasing a freezer. Where do we start? Are there requirements that you need to go by, and is there any guidance out there? What's the plan? Maybe a plan is a design qualification. And what is a design qualification? What parts are involved in a DQ? And we're going to find out after we try this DQ process. We'll figure out if that works for us, and then we'll conclude it and get to questions. So before I get started, I want to be very transparent and let you know that I was that guy who the lab manager came by and said, "Hey, Dean, we need to order a freezer." And I'm like, "No problem. What kind of freezer?" And they said, minus 20. I said, "Okay." So I opened up a catalog, I picked one, and I bought it. Well, then I got it in and I had to qualify it. Well, that wasn't working out. I just didn't get that thing qualified. It just wasn't working right. It was very close, but just wasn't getting there. So I reached back to the manufacturer and asked about, what was going on. And well, I found out some stuff about ordering a freezer, and we'll get into a little bit more about my experience later. But let's move on. How hard can it be to order a freezer? Well, I have to say it's a little harder than opening up a catalog and checking out, okay, minus 20, that works for me. A lot of things that you need to think about is, what are your business needs, and are they global? What regulations are you going to follow? What's your sample storage strategy? I mean, how do you move the samples around? How do you store them? How do you retrieve them? How much storage space do you need? That's important because in my experience, I never had enough storage space. Now, do I need backup storage space? So if I have a 30 cubic foot unit sitting over here and it fails, or I lose my monitoring system or something like that, can I move them? What am I going to do with my samples? Now, does the freezer need to be qualified? If it does, how are you going to test it? What's your testing criteria? What utilities are required? And, we're talking about electrical, maybe the temperature surrounding the unit, because if you store it, if you put your freezer in too hot of a room, that could cause issues with the performance of that freezer. And location. Now, go ahead and laugh that I brought that up, but I've seen it before. Folks will order a freezer and they won't look at the technical data sheet to see how big this thing is. And when they get it off the dock, they can't push it through their laboratory door. So you need to make sure you get the right size. And then, do you want connectivity? I mean, do you want a solution of having a system that helps you maintain the health of your freezer? And then, do you need external monitoring, which, if you're in a GMP application, you probably do. So a little help, please. I mean, come on, that's a lot of information, and I'm not sure what parts and pieces of that that I'm going to have to use. So let's take things one step at a time here. So what are the requirements, or are there requirements? So first things first, you have to determine what are your requirements. So this is something that a vendor, manufacturer of freezers, they cannot answer this question for you. You have to know what your requirements are. So in order to figure this out, you need to involve your quality team and the IT team if needed. So here again, I know I heard you guys groan when I said quality team, because we know their job is just to slow us down and make things hard, right? Well, that could not be further from the truth. You need to get these guys involved so you can address all your issues beforehand, because you don't want to go through this whole process and then hand them a request to purchase a freezer and they look at you all funny and you have to start over. So you also want to benchmark internally. So what are other areas in your group? What are they doing? How are they handling their freezer and sample management? You also want to benchmark the industry. So if you're new to this, you want to reach out and talk to people about what they're doing, especially folks that are getting audited and have audit results that they might be able to share with you. Now, some ways to do this is to join scientific societies like like I said before, ISPE and ISBR. These are very good organizations. They have guidelines like the ISB has controlled temp chambers, the commissioning and qualification mapping and monitoring guide. I keep that handy because I'm in it all the time. And then the ISBR best practices recommendations for repositories. They have a 4th edition out. These are very good places to take a look and see what's out there and to get a little bit of guidance. There's some other groups out there like the Pharmaceutical Stability Discussion Group. That's a little more focused for stability applications, but folks like that, they do in their biannual meeting, they go out and they'll share their mapping or their audit opportunities that they've had and share some of that information. So all this knowledge is super, super important. So now, where else can you get guidance? Okay. Now, once again, I have to stress, this is not something that catalog, there's nothing in the freezer catalog that's going to answer any of these questions. So where do you look for more guidance? Well, I personally, in this case, let's look at the FDA Q7 Good Manufacturing Practice Guidance for APIs or active pharmaceutical ingredients. And they say qualification, because I'm going to have to qualify this thing. Before initiating process validation activities, appropriate qualification of critical equipment and ancillary systems should be completed. Qualification is usually carried out by conducting the following activities individually or combined. So I'm going to make you wait on exactly what those are just for a few minutes. So I'll get to a little more on that offering of a regulation in a few minutes. So now we're going to need a plan. So we think we know what the requirements are. Now we're going to need a plan. So one way that I found works well is a DQ or a design qualification. And that's part of an instrument qualification package. So the design qualification in this case is, and this is as specified by the FDA, it's documented verification that the proposed design of the facilities and equipment, so there's the keyword equipment, which is our freezer, or systems is suitable for intended purpose. So that's what we need to concentrate on. So there you have it. There's a guidance out there that says, hey, maybe using a DQ is a good idea. Now, they also go on to say that they'd like to see an installation qualification, an operation qualification, and also a performance qualification. But we're not going to get into those right now. Those are all separate discussions. But if you do go to the FDA Q7, you'll see those listed as well. So now here's an example of a DQ. Now, these are kind of fuzzy, at least they are to me. This is just to kind of give you a quick visual on what an instrument qualification form might look like. And I know it's hard to read. We're going to get into parts and pieces here, but it goes step by step from the time that you decide you're going to pick a unit, and it goes through some steps until your quality unit will sign off on it. Now, I'm not going to cover anything further than the DQ today. So let's look at the parts of a DQ. So there's a change control. And if you're working in a GMP setting, you're familiar with the change control. I won't go through all of this, but the important part here is that there are 6 primary stages. The one that we're going to concentrate on is the equipment installation and validation and or the calibration. That's what we're going to focus on. So in this DQ, you're also going to simply put down the instrument type and the manufacturer. So, we're going to say, all right, we need an ultra cold freezer, and we're going to purchase it from Thermo Fisher. And the user requirements. Now, this is one of the most important parts of a DQ. This is what's going to sell it to your quality unit. So it's kind of, what do I have to have, and what would I like to have? So intended use, what is your intended use? Well, okay, today our intended use is for storing critical samples because our samples are important. And we want the desired temperature of minus 80 degrees C. All right, easy enough. Now, special requirements, ranges of operation, performance tolerances, and capability requirements. Well, in this case, I'm actually going to refer to the USP just for this example. And the USP in their general chapters, they say that if you're going to store samples colder than minus 20, you're allowed plus or minus 10 degrees C movement of the recommended storage condition. Okay, so my test acceptance criteria is plus or minus 10. Now I'm also going to need about 30 cubic foot, and I'd like some visual alarm notification. That's just what I want. I also, and I didn't put it here, but I want some connectivity as well. I mean, you know, if there's something out there that tells me that my freezer may need to get looked at or may be ready for some maintenance ahead of time, I think I would like to see some of that, and also external monitoring. That's kind of a little different. We'll cover that here in a minute. Now, another part of the DQ is the instrument design. So COTS, or commercial off the shelf, that's the one we chose. That's we put a check mark there because I don't really need a customized freezer of any kind. We had three choices. We could just use it as recommended by the vendor, which that's what I usually do. Sometimes it requires some customization. And sometimes, you know, here's a box for custom design, so you're going to have to pick. I must tell you, it's so much easier to use it commercial off the shelf, because then your manual will provide you the information on proper use, and it will also give you some information about preventative maintenance and things. So if you can go to that, that's really going to help you show that you have control over that. So now let's go to the design, qualification, and verification. So based on the vendor recommendations and specifications, or based on custom design documentation, you want to verify that the intended use is within the nominal instrument capabilities. You also need operating ranges. You want to verify that they're within the stated instrument capabilities, like we talked about before. The intended physical operation environment meets the manufacturer's recommendation. You need to check out the utilities and the facilities and make sure the proper stuff is available there. And also, computer components are compatible with your network environment. So not, you know, in that whole quality group and your IT group, you really need to be on board with those guys before you order this freezer. Now, here's some really neat, very critical documents from the manufacturer. These are the technical data sheets. And I know that this is kind of hard to see, but this is the thing that when I ask my salesperson, hey, here's my requirements on this freezer, what do you got that's going to fit? Well, their tool, they're going to go to the TDS. And the technical data sheet, it's going to cover things like what application can you use it for? What temperatures will work? What temperature range is there? What kind of power do you need? There's just a slew of information here. Usually the first couple of boxes will take care of what your needs are, but then the equipment qualification form will also guide you to talk to your building facilities folks to make sure that the facilities needed or the utilities needed for the freezer are available or can be available. So you don't want to buy something, you know, if you have a 115 volt receptacle, you sure don't want to buy a 220. unit. So TDS is a very, very important part of our decision to purchasing this freezer. Now, in this case, this kind of captures, it shows a little bit better what I was talking about. There's application, storage volume, temperature ratings, things like that. Refrigeration system, that can be important. Make sure it's Energy Star compliant. Talks about compressor, things like that. And it will also go into what kind of refrigerant is used and things like that, flammability down here. Now also is performance. So remember, we have to be plus or minus 10 of our desired temperature. So here at the bottom of the technical data sheet, it shows some performance testing that was done at the factory. Now keep in mind, the factory, they'll never know how you, or let's say us right now as a customer, is going to test this freezer. So they have no idea. So what the factory does is they figure out where to put probes so they can ensure that this freezer can operate to within the specifications that you want. But keep in mind, if you go to map this chamber with your own protocol, it's probably going to look a little different than this. Now, the operation, that won't change, but these numbers will definitely, they won't be the same, but they'll be within your acceptance criteria. Now, other considerations that I want in my freezer is remote monitoring. And if you're in GMP, you're definitely going to need that. I need to, and I can't remember which regulation it is offhand, but they say in a stability operation that you need to ensure that there's 24/7 data, or a collection of data. And so you're going to have that. When you have remote monitoring, it provides operational efficiency, compliance, and quality. It answers all those questions. Here's improved science results, and part of the reason that that's out there is because if you're looking at your monitoring system, and even before you get an alarm, if you see that you want it to be a little tighter or something like that, or if it's not performing exactly right, you can go ahead and put in a work order to have it looked at. Sample security is also another one. This thing is going to, remote monitoring tells you when the door was opened, how long a door was opened, things like that. Equipment optimization, of course, like I mentioned before, it's going to tell you, it's showing indication that the freezer is running correctly. And of course, that's going to give you peace of mind that everything's fine. So, that's, in this case, we want remote monitoring. So let's see. Now, everything that we looked at with that TDS and all the information per the regulations that we looked at, we need to double check and make sure that this freezer fits our purpose. So, desired temp of minus 80. Yep, that fits. Do we have enough space for storage? Well, I didn't focus on it on the TDS, but this particular freezer has about 28 and some change cubic feet of storage space. So that's close enough for the 30 that I was looking for. The testing criteria, does it meet the testing criteria? Well, the range that I saw on the graph was about, had a peak variance of around 4. So that's plus or minus 2, sort of. So my peak variance is 2, that's plus or minus 4. So, oh yeah, that very well meets the plus or minus 10 criteria that I needed. Now, does it have visual alarm notification? Well, I didn't focus on that, but in this case, the unit, it does have a sound that comes out of it. And then, in case of an alarm, and there's a visual alarm notification. In this case, it's a light bar at the bottom that lights up. So like if it's working right, it's green. If it's kind of not working right, it's yellow. And if it's an alarm, it'll show red. And probably you can set up a sound alarm as well. And does this one have connectivity? Absolutely it did. So we're looking good so far. All right. So now what do? We have answered all these questions. The first thing that we did was develop a plan. And the plan was to include our quality and IT groups, benchmark internally and externally. We've decided to use a suggested process called a DQ, or design qualification. We filled that form out, and we figured out that everything worked out fine for us in this case. So now what do? Now it's easy. Let's buy it. So we've covered all the steps to make sure that our samples are going to be safe. We have plenty of documentation showing that the unit is going to operate within our temperature, and that we should be able to qualify this thing with our own protocol. So the bottom line is, will it fit? In this case, yeah. So we can go on to that qualification form in the DQ part and sign that off, take it to our quality unit and say, hey, we've done our homework. This is what we're going to use it for. This is the information that we have to purchase or to prove that this thing is going to work for us. And so your quality unit will probably be more apt to let you buy this thing. So now, what happened to that freezer that I purchased in the beginning of my career for that laboratory? Well, I guess at first I was a little embarrassed, but I became a hero in some sorts, because I had to go to my facility manager and say, hey, I've got this freezer I can't use. I have to order a freezer that fits the purpose of my business. Do you need this freezer? And he was jumping up and down, and they ended up using the new freezer in the break room. So I was the guy for the first couple of years of my career known for getting a brand new freezer for the break room. And that was a feat that the facility guys wasn't able to do for several years. So anyway, it didn't hurt at all. Okay, so the conclusion is there are many ways or processes to purchase the correct freezer. So in this case, we used the DQ. Again, this is only one example. There are many ways to do a DQ. Or there are several processes to use, but I usually try to use the guidance that is out there, especially by the FDA and other auditing bodies. They really tell you what form, in what format they want to see the information. So again, I can't stress enough. We planned ahead. We involved our quality team. You also need to include your IT folks as well. Now, I'm going to put my auditor hat on just for one moment. So when I would go and audit internally or even externally, the one thing that I looked for specifically was, do you have control of your business? And how I would determine that is the documentation that backed up all of the answers that you give me. So for example, if I would say, hey, what are you using the freezer for? And you would say, Well, we're storing our critical samples in there, and it's at minus, our desired temp was minus 20, and we got our minus 80, and our acceptance limits on our testing protocol was plus or minus 10. My next question would be, well, my goodness, well, how do you back that up? How did you determine that? And then you would say, well, we looked at some guidance issues through the FDA, and we referenced the USP, and that fit our business. So we went to our quality unit and we put a strategy in place to do that. The same could be said about monitoring systems. A good question that I love to ask is, what is the temperature of your freezer? And the answer that is the most popular, it comes from one specific place. So hopefully you have set up your strategy document. If it's a monitoring system, external monitoring, to be specific, you want to make sure that you only have one place to get that temperature. You can have backups for that, and that's appropriate. But if you give two answers, well, maybe the display and maybe the monitoring system, well, those two are never going to match. So that's probably not the best answer, and you might want to think about how you're going to answer that question. So that's it. I hope this was helpful. I know in the beginning people think, oh my gosh, how hard is it to order a freezer? I found out it's not hard, but it's a little complicated the first time to make sure that you do it right and that you fulfill all your requirements. Luckily, I became a hero in the break room. And then because we didn't have a really robust process to purchase a freezer, after my ordeal, I wrote the process. And to be honest, that process in some manner is still being used today. And I think I wrote my first one in 1996. So anyway, I would like to thank you very much for your time, and I will open it up for questions.
Thank you, Dean, for your informative presentation. We will now start the live Q&A portion of the webinar. If you have a question you'd like to ask, please do so now. Just click on the Ask a Question box located on the far left of your screen. We'll answer as many of your questions as we have time for. So let's get started. Our first question is, what regulations should a GMP laboratory follow?
Okay, fair question. The hardest part about being an applications manager is not being able to answer a question with a very specific answer. So in this case, like I mentioned before, you have to determine ahead of time through benchmarking internally and externally to figure out what is your business, what are other people doing in your business, and then you can start going down that path of what the regulations should be. And if you go to the FDA for guidance and some of the other organizations that I mentioned, that should get you on the right path. So thank you.
Great, thank you. Next question. Where do I find the test criteria for my storage application?
Well, the test criteria, that's kind of the same answer. The test criteria, you need to set up testing or to write your protocol based on what makes scientific sense to you. So I usually have folks write what I would call a strategy document to start with. So once you've done your benchmarking and you've done all those types of things, then you would kind of get to that point of, if you're going, in our case, we followed the USP guidance, which said plus or minus 10. So that's what we used. Now, a good example would be, let's say you had plus or minus 10, but now your scientists came back and they said, oh, I don't know if that's going to work. Maybe it should be plus or minus 9 because something that could happen to our product. Then, of course, you can tighten that down and justify it in your strategy document. So thank you.
Great, thank you. Next question. Does a lab or company need to consider the international regulations if the stored product might be sold internationally?
That's a very good question. The answer to that is absolutely. When I was doing stability, when I was managing the stability area, we were global, just like reference standards was. So it took us quite some time to go through and look at every place where we're going to sell the product or where that product was going to go for testing, manufacturing, or whatever, packaging maybe. And you look at the rules and regulations of each country. Then you combine all those. And what we did, we picked the worst case scenario. And so we used that worst case, but we did reference all of the other regulations in our strategy document. So it was quite a lengthy process. I think it took about 3 folks, to be honest, to get it all right and approved, about 6 months to get that done. So yeah, great question. That's a tough one to get done.
Okay. All right, thank you. Next question. Which specific connectivity solutions can help with complying with monitoring regulations?
Yeah, well, there's a bunch, and I'll start off, and I'll take it from the customer standpoint, and then I might defer to Josh and see if he make sure I caught everything. But the first thing is an asset manager. I'm going to want a unit that will let me know before it breaks. So if this thing starts acting a little funny, if someone gives me that information ahead of time before it goes into alarm, that keeps my samples safer longer. So if there is a problem, I can move the samples and maybe put a work order in before anything ever truly goes out of whack. The other thing, the temperature monitoring piece, that's critical. I mean, you have to have that in a GMP setting, and it has to be robust and qualified. And of course, you have to be able to calibrate it periodically. So to me, you can't do GMP without some sort of connectivity. So, Josh, do you have anything to add?
Thanks, Dean. Yeah, I think I would add a couple points. When we talk about regulations with regard to monitoring, one of the most important facets of that is the complete audit log and audit history. So a lot of monitoring solutions, some that are kind of built into systems and aren't independent per se, they may not have a complete or robust enough audit log with traceable features. And I'm not necessarily speaking to a 21 CFR type of compliance, but simply an uneditable version of that audit history is really key for any type of record keeping. On top of that, kind of to what Dean was alluding to as well, when it comes to the validation aspect, a lot of remote monitoring systems can also be used to really, with multiple sensors, for example, throughout your cabinet, to give you a better look into how your cabinet is performing over time, and maybe help you preempt a failure out of validation criteria within the given year or standard operating window that you're looking at. So kind of having a glimpse into how is your freezer performing over time, and not just at your regular cadence of validation, revalidation windows. So it's something to consider there as well.
Great, thank you. Next question. What happens if the freezer is not performing as intended?
Well, I'm just going to, and I know you're not supposed to assume, but I'm going to assume that your monitoring system is telling you that it's not working correctly. So in most situations, you've already had to set up, and if you went through the whole qualification form, it's going to make you address your maintenance schedules and what to do in case it does fail. Let's say you get an alarm, the first thing you would do is respond in your monitoring system accordingly, and then all hands on deck, you would go start to troubleshoot the freezer. So the two things that you would do, the first thing, I would have my service folks put a NIST traceable temperature standard in there and see what the temperature really is, make sure your monitoring system is working properly. So I always tell people you got to figure out who's lying to you, or who failed. And so you determine right away, is it my monitoring system or is it really the freezer? If it is a freezer, because it's 30, in my case, it was 30 cubic feet or less for stand-up applications, I would always have backup units available. So if the temperature was not what it was supposed to be, I could immediately move my samples out of harm's way. And then, of course, you would have to update the your inventory log, of course. But then that starts a whole process of your samples are safe. Now you have to document that they're safe, and then you put in a work order to find out what the problem is. So.
Great. Thank you. Next question. Do you have any suggestions for backing the power up or responding to an event in which a power outage occurs?
Okay, so backup systems is actually a class. So I'll touch on that just a little bit. Backup power, you have to remember, if you're going to back up a unit, you should probably have what we would call in the business a disaster recovery plan. And in this case, a disaster would be loss in power. And what I do and what was used in the business is very common is we would use backup generators on the building circuits that our critical storage units were attached to. Now, we provide battery backup for the display, and in that case, it would not, the refrigeration system wouldn't be working, but it would keep the display collecting data, and when the power did come back on, it would start back where it ended. You would still have your set point, it would still operate like that. Now, we do have some units that have a LN2 backup system. These are not really made to be qualified, like mapped, but it does allow you some time to respond to a failed freezer if in fact it does fail. So like I said, backup, that's a whole class. So I hope that helped.
Great, thank you. Next question. What is it? Oh, sorry.
Yes. Go ahead, Josh.
No, I just wanted to add one thing when we talk about backup systems or backup power, you have to be really conscientious around what type of power supplies or backup generators that system that you're using with an ultra-low temperature freezer specifically, because of the inrush current of the refrigeration system. So when you do that, make sure that you are conforming to the technical data sheet, that same sheet that we referenced with regard to performance of the unit. There is always electrical specifications on that sheet. If you don't match it accordingly, you could basically have a non-functioning backup power system. Okay, so just make sure of that.
Oh, no. Yeah, thanks for that. Thank you.
All right, next question. What is a typical lead time to order a freezer? And please outline the timing of the whole process, the purchasing and qualification.
Okay. So the lead times, from the time that you decide to order a freezer and you start the process and you've never done it before, but let's say you have the qualification form already in hand, it's pre-approved by quality to do. If you really move quick, you can fulfill the DQ portion of that and get the freezer ordered probably inside of a week, depending on how fast your business moves. I mean, if you're going to a manufacturer that supplies all the information that I talked about, the TDS sheets and end-of-line testing and things like that, then that information is going to be very easy to acquire and to staple to the back of that. Lead times, we're all in hard times right now. I honestly don't know what the actual manufacturing lead time is, but that would come into play right now as well. But by the time you get done doing the paperwork and you order the freezer, you go through the qualification aspect of it, it arrives on your dock, you get it qualified, it's not uncommon for this to take anywhere from 4 to 6 months. It can go less if you have everything in place, everything's ready to go. But I've never found that to be the case in my experience, actually. So did I cover all the aspects of that question?
Yes, I think so.
Okay.
Thank you.
Thank you.
Okay, next question. Can we use 100% ethanol to store our digital probe?
So, sorry, I hesitated because that's a very loaded question, believe it or not. Just for the simple fact that I can't really comment on putting a probe in ethanol. I personally have never done it. Back years and years ago, we would put our probes in glycol or something similar to buffer alarms. Most folks are getting away from that now because most regulations state that you store the product in the condition of -80, so they do not want the condition of glycol at -80 or ethanol. So I have to be honest, I can't really answer that. And I'm not sure which probe. If it's the monitoring probe, common practice in the businesses that I've been associated with is to put your monitoring probe in the air. And then if you're worried about buffering alarms during the qualification, you would do an open and closed or open door study to simulate retrieving a sample, let's say. And then you would take a look at what happened to your freezer temperature. I used to do a 1-minute open door study. So I would open the door, open up the internal doors for 1 minute, and then close it. And then I would see, did it go back in spec in 10 minutes? Did it go out of spec at all? And then I would add a little time. And that way you could set what we would call alarm delays in your monitoring system. So when the unit would go out of spec, once it went out of spec, the clock would start. What was common on all temps, except for the ultra cold, was a half hour in my application. And that gave us plenty of time to open and close the door to get the samples. So hopefully I answered that question.
Hey, Dean, can I chime in?
Absolutely.
So it might be beneficial when you're asking that kind of question to look at the various standards in the market. One primary example that has been used, at least in the industry for the last few years, has actually been the EPA Energy Star test procedure, which might be a good reference point as to how you monitor or kind of weighting you would use on your probes. In that standard, when we do that practice, it's actually a 50-50 glycol and water solution. The alternate method to that is using a similar thermal mass. A lot of the industry is going to a copper or a brass type of solid material with the same thermal mass as that 50-50 glycol water solution. Effectively, that's the thermal weighting that you're looking for.
Great. Thanks, Josh.
And it looks like we have time for one more question. I know a UPS backup won't supply enough power for the freezers in the event of a power outage. What is the best way to prevent loss of power or recover from such an outage if only depending on a generator?
Okay, so I'm assuming that you're running off of building power, and then is the question that you have a backup generator available, or are you just running on a generator? So if in practice, I'll take it from both aspects. If you have building power already and you have a backup generator in place, usually that turns on two ways. It's usually automatic with a switching mechanism at the electrical box. So if you lost power, it's only a matter of a second or two that the generator kicks on and takes over, and then you would have to manually switch it back over once the power became available. If you're in a situation where you're running on a generator, you would either have to have another generator or a separate, someplace else to store the samples. So even if it's offsite, I know it's not uncommon for big pharma companies. They'll have backup generators, but not only that, somewhere close to them will be a business that all they do is have storage temperature available, so you can set up a contract with that in case of an emergency. So I hope that hit the direction. Go ahead, Josh.
Yeah, no, I was just going to add, regardless of whether on main line power or on generators, one thing to think about is if you have more than one laboratory equipment device, whether it be a ULT freezer, refrigerator, or whatever, when that power is restored or in the time it takes for a generator to kick in, you're going to have equipment trying to come back online or powering up all at one time. That's a huge amount of current that's going to be pulled from that generator. One thing that you can consider is a lot of devices have the ability to set a delay timing. So if you have, for example, 3 freezers in one room, you could say set freezer 1 to come on back immediately, set freezer 2 to wait a minute, and set freezer 3 to wait 2 minutes. That way you don't have that dramatic inrush of current all at one time, and you can stair-step your lab to come back on power. That would help to avoid additional power loss or equipment failures once you do experience a loss of power.
No, that's great. And that just made me think of another thing. In the application that I had in the laboratories, the engineers that managed the building would only allow me 50% of the generator space could be used just in case a lot of stuff started up at the same time. So yeah, that's a good question. So thank you all very much. I appreciate that.
Great. Well, thank you, Dean. Do you have any final comments for our audience?
Well, sure. Again, I'd like to thank you for taking the time out of your busy day to attend the webinar. It's a passion of mine to talk about my experiences and things like that. So maybe folks can not have to purchase all of those break room freezers to start out like I did. And also, if you have any questions later, you can contact me at dean.rainbolt@thermofisher.com. And if I don't know the answer, as you can see, I have plenty of expert help that I can go to get those questions answered. So that's it. Thank you very much.
Well, great. Thank you again, Dean, for your time today and your important research. We would also like to thank LabRoots and our sponsor, Thermo Fisher Scientific, for underwriting today's educational webcast. Before we go, I'd like to thank the audience for joining us today and for their interesting questions. Questions we did not have time for today and those submitted during the on-demand period will be addressed by the speaker via the contact information you provided at the time of registration. This webcast can be viewed on demand. LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. Until next time, goodbye.